Yeah, you. I just have a really quick question. Do you know how to solve for this one, this one, this one, or maybe that one? No? Gosh, math is so hard, right? But don't you worry, because in group 5, we will teach you on how to add or subtract some radicals. But before we get started, let me introduce you to my 5 friends, including me. These 5 friends will help you to understand adding and subtracting radicals really easily with only just 3 steps. Okay, so before we really get into this video, I have 3 mighty objectives for you guys to accomplish before we end this video. First objective is to learn the steps on how to add and subtract with the same radicands. Second objective is you have to learn how to add and subtract with different radicands this time. And third and last one is we have to understand these lessons and add these steps on how to solve it correctly. So now we must not late because Patrick is
To
here.
add and subtract radicals with the same radicands, you will have to follow 3 easy steps. First, determine if they have the same radicand. Second, add or subtract the coefficients. And lastly, copy the radicand and index of both numbers. For example, 3 square root of 5 plus 2 square root of 5. First, determine if they have the same radicand. They both have the same radicand of 5, so that means they are similar. Second, add or subtract the coefficients. Because the operation is addition, we will add both 3 and 2, which is equal to 5. Lastly, copy the radicand and the index. The radicand is 5 and the index is 2. The answer is 5 square root of 5. When the index is 2, you don't have to write it because it is understood that the radical does not have an index. It means it is a square root and it has the index of 2. Let's have another example. 6 square root of 5 minus 4 square root of 5. This time, our operation is subtraction. First, determine if they have the same radicand. In this case, they do. Next, subtract the coefficients 6 and 4, which equal to 2. And lastly, copy the index and the radicand. The answer is 2 square root of 2. Let's have an example with cube roots. 3 cube root of 7 plus 5 cube root of 7. Apply the same steps from earlier. Both have the same radicand, which is 7, and index, which is 3. Next, add the coefficients which equal to 8 and then just copy the radicand and the index. The answer is 8 cube root of 7. Let's have one last example. 9 cube root of 2 minus 4 cube root of 2. Again, apply the same steps. Both have the same radicand and index, which is 2 and 3. Subtract the coefficients, which equal to 5. And copy the radical and index. The answer is 5 cube root of 2.
To deepen what Patrick said, I'm here to give some examples about adding and subtracting with the same radicands. For the first example, we have 7 square root of 3 plus 4 square root of 3, and we get 11 square root of 3. Second, we have 5 square root of 2 plus square root of 2, and we get 6 square root of 2. Third, we have 9 square root of 7 plus 3 square root of 7, and we get 12 square root of 7. And for the first example of subtraction, we have 10 square root of 3 plus minus 3 square root of 3, and we get 7 square root of 3. And second, 8 square root of 2 minus square root of 2, and we get 7 square root of 2. Third, we have 12 square root of 7 minus 5 square root of 7, and we get 7 square root of 7. And now we have the examples of 2 to the 4th square root of 5 plus the 4th root of 5, and we get 9 to the 4th root of 5. Now for the next example of that, we 6 to the 4th root of 11 plus 4th root of 11, and we get 5 to the 4th root of 11. Thank you.
So, how to add or subtract the different radicals? We have 3 easy steps for this. First step, we simplify each radicand if they have the perfect square root in their index. Step 2, rewrite the expressions using the simplified radicals. Then step 3, we add or subtract like terms. If it cannot be added or subtracted, just leave it as it is. We have to take example for this. Square root of 8 plus square root of 18. Let's go back to step 1. Simplify each radicand if they have the perfect square root. Square root of 8 has a square root factor of 4 multiplied by 2. We can simplify the square root of 4 into 2. Then leave the square root of 2 inside the radical side. Meaning square root of 8 can be simplified into 2 square root of 2. Now let us solve for square root of 18. Square root of 18 has a perfect square factor, which is 9 multiplied by 2. We can simplify 9 into 3 and leave square root of 2 inside the radical side, meaning the square root of 18 can be simplified into 3 square root of 2. Step 2. Rewrite the expressions using the simplified radicals, which is 2 square root of 2 plus 3 square root of 2. Then step 3, add or subtract the like terms. If it cannot be added or subtracted, then just leave it as it is. But since then they have the same radicand now, you can add the coefficients, which is 3 plus 2, turning into 5. Then copy the radicand, which is square root of 2. So the answer is 5 square root of 2. Let's do the same with this. Square root of 50 minus square root of 8. I hope you can solve this, since it's just the same thing, same process we just did. But this time we have to subtract. It's subtraction, not addition. Let me give you more examples. With first example, cube root of 54 plus cube root of 16. Example 2, cube root of 54 again minus cube root of 16. But this time, step 1, instead of finding the square root, this time you have to find the cube root. Shown in this example, it is a cube root, not a square root.
For more examples, let us try square root of 12 plus square root of 27. Firstly, we're gonna get the factors of the radicands. So the factors of 12 is 4 and 3, and the factors of 27 is 9 and 3. After that, we get the square root of the perfect cubes. 4 and 3 will be 2 square root of 3, and the square root of 9 and 3 will be 3 square root of 3. After that, we're gonna apply both coefficients. So 2 plus 3 will be 5 and 3. Will become 5. So the final answer will be 5 square root of 3. For another example, square root of cube root of 40 plus cube root of 320. We're gonna get the factors of the radicands. So the factors of 40 is 8 and 5, and the factors of 320 is 64 and 5. After that, we're gonna get the square root of the perfect cubes. So 8 and 5 will be 2 cube square root of 5, and 64 and 5 will be 4 cube root of 5. Since there's a cube, we're gonna copy it here. Now we're gonna add both coefficients. So 2 plus 4 will become 6, and the final answer will be 6 cube root of 5. And another example is 4 square root of 12 minus square root of 75. Then we're gonna get the factors. So 12 is 4 and 3, and the factors of 75 is 25 and 3. After that, we're gonna get the square roots of the perfect squares. So 4 and 3 will be 2 and 3. I mean 2 square root of 3, and 25 and 3 will be 5 square root of 3. After that, we subtract both coefficients since it's minus. So the final answer will be is 3 square root of 3.
And that's a wrap for adding and subtracting radicals. So, did you learn anything? If yes, then go ahead and challenge yourself with these 5 practice questions we prepared. They're the perfect way to see if you really get the hang of it. Here's a secret. Adding and subtracting radicals is easy when you understand the roots and factors. Just like a puzzle, you can only combine the ones that match perfectly. Remember this golden rule. If the radicals aren't the same, then simplify. The key is to first simplify whenever possible and identify if the radicands are like radicals. Math can become so much easier when you learn how to approach it step by step. Nothing is impossible, especially with Group 5 at your back. We will give you the tips, tricks, and support you need to master even the trickiest of problems.